Welcome to the Vitality Equation, exploring research in health and well-being one paper at a time. All right, everyone, excited to dive into today's topic. This one's got some real potential for impacting people's lives in a very practical way.
Definitely. This paper, a genetic driver of epileptic encephalopathy impairs gating of synaptic glycolysis, is dense, but the implications are huge. It's about how a specific genetic issue affects how the brain uses energy, specifically at the synapses, and how that can lead to epileptic encephalopathy.
Epileptic encephalopathy, just for clarity, that's a severe form of epilepsy, often starting in childhood, right? And it's not just the seizures, it can involve cognitive and developmental delays too. So, understanding the root cause, like this genetic driver, is incredibly important.
Exactly. And the paper drills down into the nitty-gritty of how a specific gene, when mutated, messes with a process called synaptic glycolysis.
Oh, glycolysis.
As we know, is how cells break down glucose for energy. So it's about how the brain cells get the fuel they need to function properly.
And the gating part is crucial. It's like a gatekeeper that controls the flow of glucose into the synapses, which are the connections between neurons. If that gate is broken, the synapses don't get enough energy, leading to dysfunction.
Okay, so it's like a supply chain issue within the brain cells themselves. If the synapses are energy starved, that's going to affect everything: signaling, communication, and ultimately brain function. That makes total sense why it would manifest as seizures and cognitive problems.
Precisely. And that's where it gets really interesting, because if we can understand how this gate works or doesn't work, we might be able to find ways to influence it, maybe even repair it or bypass it. And that's where lifestyle interventions come in.
I'm already thinking about the cognitive angles here. If the core issue is inefficient energy use at the synapses, could specific cognitive training exercises help strengthen those synaptic connections and, in effect, improve the gating process over time?
And I'm immediately thinking about the role of sleep and exercise. We know both are crucial for brain health and energy regulation. Could targeted exercise routines or optimized sleep schedules help to improve glucose metabolism in the brain and mitigate the effects of this genetic defect?
Yes, and that's exactly where my mind went too. The paper itself might focus on the genetic and molecular mechanisms, but the implications for lifestyle are profound. Think about it. If we can influence glucose metabolism in the brain through non-pharmacological means, that's a huge win for preventative and holistic health.
I agree. It's not just about treating the symptoms with medication, it's about addressing the underlying metabolic dysfunction. That shifts the paradigm completely.
It really does. So let's break down the science a bit more. What exactly did the researchers discover about this genetic driver and its impact on glycolysis?
Okay, so the paper identifies a specific gene, and when it's mutated, it disrupts the normal function of a protein involved in transporting glucose into the synapses. This protein acts like a gatekeeper, carefully controlling how much glucose enters the synapse. When the gene is mutated, the gate malfunctions and the synapse doesn't get enough glucose.
And it's not just any glucose, it's specifically glycolytic glucose, the glucose that's broken down for immediate energy. So the synapses are essentially running on empty.
And that lack of energy probably makes the neurons more vulnerable to excitotoxicity, which is when they get overstimulated and damaged, leading to seizures. Is that a fair assessment?
Exactly. Think of it like a car engine running on low fuel. It might sputter and stall or even overheat. Similarly, energy-starved neurons are more prone to misfiring and causing seizures.
So knowing this, let's brainstorm some potential interventions. Otto, you mentioned cognitive training. Can you elaborate on that?
Yeah, so we know that the brain is incredibly plastic. It can adapt and rewire itself in response to experience. If the synapses are weak due to energy deficiency, maybe we can strengthen them through targeted cognitive exercises. Think of it like physical therapy for the brain.
I like that. Could it be that certain types of mental exercises might stimulate glucose uptake or improve the efficiency of glycolysis in those specific brain regions?
Potentially. It's speculative at this stage, but it's definitely worth investigating. For example, tasks that require focused attention and working memory are known to be metabolically demanding. Maybe these types of exercises could help to train the synapses to utilize glucose more efficiently.
And even things like mindfulness and meditation. We know that these practices can reduce stress and improve focus. Could they also have a direct impact on glucose metabolism in the brain? Maybe by reducing the overall energy demands of the brain, They allow the synapses to function more efficiently with the limited glucose available.
That's a fascinating thought. Stress hormones definitely impact blood sugar and energy utilization. If meditation helps to regulate the stress response, it could indirectly improve glucose availability to the brain.
Yes, and it also ties into cognitive restructuring techniques used in CBT. If someone with this genetic predisposition is prone to anxiety or negative thought patterns, those patterns themselves consume mental energy. By learning to manage those thoughts, they might free up more energy for essential synaptic function.
Exactly. It's about optimizing the brain's energy budget. And what about the diet side of things? Are there specific dietary interventions that could help to improve glucose metabolism in the brain, given this genetic defect?
Well, the ketogenic diet, which is high in fat and very low in carbohydrates, comes to mind. It forces the body to use ketones, derived from fat, as an alternative fuel source. Could ketones bypass the impaired glycolysis pathway and provide energy to the synapses in a different way?
That's a valid point. And there's some preliminary research suggesting that the ketogenic diet can be helpful for some types of epilepsy. But it's a very restrictive diet, and it's not suitable for everyone. Plus, the long-term effects are still not fully understood.
Right. It has to be approached with caution and under medical supervision. But what about more subtle dietary changes? Are there specific nutrients or supplements that could support glucose metabolism or protect the synapses from damage?
Things like omega-3 fatty acids, which are known to be important for brain health, might play a role in supporting synaptic function and reducing inflammation. And there's some evidence that antioxidants, like those found in berries and leafy green vegetables, could protect neurons from oxidative stress, which can be exacerbated by energy deficiency.
And again, this is where personalized medicine comes in. What works for one person might not work for another. It's crucial to consider individual genetics, lifestyle, and other health conditions when designing a dietary intervention.
Absolutely. And what about the exercise piece, Sarah? How could targeted exercise routines potentially help in this situation?
Okay, so exercise is a potent regulator of glucose metabolism throughout the body. When you exercise, your muscles use glucose for energy, which helps to improve insulin sensitivity and regulate blood sugar levels. And that, in turn, can have a positive impact on glucose metabolism in the brain.
So it's like a systemic effect. Improving glucose metabolism in the body as a whole makes it easier for the brain to access and utilize glucose.
Exactly. And there's also evidence that exercise can increase the production of brain-derived neurotrophic factor BDNF, which is a protein that supports the growth, survival, and function of neurons. So, exercise could potentially help to strengthen synaptic connections and improve overall brain health.
That's huge. And what type of exercise would be most beneficial? Is it cardio, strength training, or a combination of both?
That's a great question, and the answer is probably both. Cardio exercise can improve insulin sensitivity and blood sugar control, while strength training can build muscle mass, which further enhances glucose utilization. A combination of both is likely the most effective approach.
And I'm thinking about the cognitive benefits of exercise as well. We know that exercise can improve mood, reduce stress, and enhance cognitive function. All of those things can indirectly support brain health and potentially mitigate the effects of this genetic defect.
Right. It's not just about the physical effects. It's about the mental and emotional benefits as well. And let's not forget about sleep. Sarah, you're the sleep expert. How does sleep fit into this picture?
Sleep is absolutely critical for brain health and energy regulation. During sleep, the brain clears out toxins and consolidates memories. It also restores energy reserves and repairs damaged cells. So, if someone is sleep deprived, their brain is not functioning at its best, and it's going to be even more vulnerable to the effects of this genetic defect.
So, sleep deprivation could essentially exacerbate the energy deficiency at the synapses.
Exactly. And certain sleep phases, like slow wave sleep, are particularly important for brain restoration and energy replenishment. So, optimizing sleep quality and duration is essential for mitigating the effects of this genetic defect.
And that means not just getting enough sleep, but also ensuring that the sleep is deep and restorative. Are there any specific strategies for improving sleep quality in this context?
Absolutely. Things like maintaining a regular sleep schedule, creating a relaxing bedtime routine, and avoiding caffeine and alcohol before bed can all help to improve sleep quality. And in some cases, sleep aids or other interventions might be necessary, but those should always be discussed with a healthcare professional.
And from a cognitive perspective, sleep hygiene is key. Reducing screen time before bed, creating a dark and quiet sleep environment, and practicing relaxation techniques can all help to calm the mind and promote restful sleep.
Okay, so we've covered cognitive training, diet, exercise, and sleep. All of these lifestyle interventions have the potential to impact glucose metabolism in the brain and mitigate the effects of this genetic defect. But how do we translate this knowledge into real-world applications?
That's the million-dollar question. I think the first step is to raise awareness among healthcare professionals and the general public about the importance of lifestyle interventions for brain health.
And we need more research to investigate the specific effects of these interventions on glucose metabolism in the brain. We need to conduct clinical trials to see if these interventions can actually improve outcomes for people with this genetic defect.
Definitely. And it's important to remember that this is a complex condition and there's no one-size-fits-all solution. A personalized approach is essential. We need to tailor interventions to the individual needs and preferences of each person.
Exactly. What works for one person might not work for another. Some people might respond well to cognitive training, while others might benefit more from dietary changes or exercise.
And it's crucial to monitor progress and adjust the interventions as needed. This is not a set it and forget it approach. It requires ongoing assessment and adaptation.
So, what about specific examples? Can we think of some real-world scenarios where these interventions could make a difference?
Sure. Imagine a child who is diagnosed with epileptic encephalopathy due to this genetic defect. In addition to medication, their doctor could recommend a comprehensive lifestyle program that includes targeted cognitive training exercises, a balanced diet rich in omega-3 fatty acids and antioxidants, regular physical activity, and optimized sleep hygiene.
And the cognitive training could focus on improving attention, working memory, and executive function. These are all cognitive skills that are often impaired in people with epileptic encephalopathy.
And the diet could be tailored to their individual needs and preferences. Some children might benefit from a ketogenic diet, while others might do better with a more balanced approach that focuses on whole unprocessed foods.
And the exercise program could be designed to be fun and engaging so that the child is more likely to stick with it. It could include activities like swimming, biking, or playing sports.
And the sleep hygiene program could focus on creating a relaxing bedtime routine, reducing screen time before bed, and optimizing the sleep environment.
And all of these interventions would be monitored closely by a team of healthcare professionals, including a neurologist, a dietitian, a cognitive therapist, and a sleep specialist.
That's a comprehensive and holistic approach, and it has the potential to significantly improve the child's quality of life and reduce the severity of their seizures and cognitive impairments.
And it's not just for children. These interventions could also be beneficial for adults who are diagnosed with epileptic encephalopathy due to this genetic defect.
Absolutely. It's never too late to adopt a healthier lifestyle and improve brain health, and even small changes can make a big difference.
So, what are some of the challenges in implementing these lifestyle interventions in the real world?
One of the biggest challenges is access to care. Not everyone has access to the healthcare professionals and resources that are needed to implement these interventions effectively.
And cost is another major barrier. Cognitive therapy, dietary counseling, and sleep studies can all be expensive, and not everyone can afford them.
And there's also the issue of motivation. It can be difficult to stick with these interventions long-term, especially if you're not seeing immediate results.
And there's the challenge of individual variability. What works for one person might not work for another. It's crucial to find the right combination of interventions that is tailored to the individual needs and preferences of each person.
So, how do we overcome these challenges?
We need to advocate for policies that increase access to care and reduce the cost of these interventions. And we need to develop more affordable and accessible resources, such as online cognitive training programs and community-based exercise programs.
And we need to educate people about the importance of lifestyle interventions for brain health and provide them with the tools and support that they need to make lasting changes.
And we need to continue to conduct research to investigate the specific effects of these interventions on glucose metabolism in the brain and to develop more effective and personalized approaches.
Yes, and I would add that we need to be more aware of the socioeconomic factors that impact health and well-being. This genetic predisposition doesn't discriminate, but access to resources and support certainly does.
Absolutely, Sarah. That's a crucial point. Socioeconomic disparities can significantly impact access to healthy food, safe environments for exercise, and quality healthcare, all of which are essential for managing this condition.
So we need to be mindful of these disparities and tailor our interventions accordingly. For example, we might need to provide transportation assistance to help people get to appointments or offer free or low-cost healthy food options.
Or we could partner with community organizations to offer exercise programs in underserved neighborhoods. And we could develop culturally appropriate educational materials that are tailored to the needs of diverse populations.
And we need to be sensitive to the cultural beliefs and practices of different communities. Some cultures might have different attitudes towards healthcare and lifestyle interventions, and we need to respect those differences.
So it's about being culturally competent and providing equitable access to care and resources.
Exactly. And that requires a collaborative effort involving healthcare professionals, community organizations, policymakers, and individuals.
And it requires a long-term commitment to addressing the root causes of health disparities and creating a more just and equitable society.
All right, this has been a really insightful discussion. We've covered a lot of ground, from the molecular mechanisms of this genetic defect to the potential of lifestyle interventions to improve outcomes for people with epileptic encephalopathy. Let's talk about the future. From each of our perspectives, where should future research go?
From my perspective, I'd love to see more research on the specific types of exercise that are most beneficial for improving glucose metabolism in the brain. Are there specific muscle groups or exercise intensities that are particularly effective? And how does the timing of exercise, relative to meals or sleep, impact its effects on brain function?
I'm interested in exploring the cognitive aspects further. How can we develop more targeted cognitive training exercises that specifically address the deficits caused by this genetic defect? And can we use neuroimaging techniques to monitor the effects of these interventions on brain activity and connectivity?
And I'm fascinated by the potential of mind-body practices like meditation and yoga to influence glucose metabolism in the brain. How do these practices affect stress hormones and inflammation? And how do those effects translate into improved brain function? I'd also be curious to see how dietary changes in mindful eating could further enhance those benefits.
And I think it's important to investigate the long-term effects of these interventions. How do they impact brain development and aging? And can they prevent or delay the onset of other neurological disorders?
And we need to conduct more clinical trials to compare the effectiveness of different interventions and to identify the optimal combination of treatments for each individual.
And we need to continue to advocate for policies that support research and innovation in this area, and that ensure that everyone has access to the care and resources that they need to live healthy and fulfilling lives.
Yes, and I'd add that it's so important to include diverse populations in these research studies so that we can ensure that our findings are applicable to everyone.
Absolutely. And we need to engage with community members and stakeholders throughout the research process to ensure that our research is relevant and responsive to their needs.
Okay, fantastic points all around. This has been a truly illuminating discussion highlighting the interconnectedness of genetics, lifestyle, and brain health. It really underscores that a holistic approach addressing both the mind and body is key to improving outcomes for people with this challenging condition.
Definitely. It's empowering to see how lifestyle choices can have such a profound impact on our health, even at the level of cellular metabolism.
And it reminds us that we are not simply victims of our genetics. We have the power to influence our own health and well-being through the choices we make every day.
Wonderful. Thanks for joining me to discuss, and thank you all for listening. We'll be back next week with another deep dive into health and well-being research. Until then, take care and stay curious.